Okay, so my program was Trivia Hangman. This was for Mr. Mayo's Computer Science Period 2. So, how is Trivia Hangman played? Trivia Hangman is a user-friendly, easy-to-play, and fun game for all ages. Trivia Hangman is simple. Upon starting the program, the user will be greeted with a numbered menu, which will be 1 through 3, and it will consist of 3 playing options. Superheroes, which are like superheroes like such as Batman, Superman, and you'll be told to guess their names. Geography, these will be major countries: Mexico, United States, Canada. And coding terms, which will be simple coding terms from C++, such as cout, cin, vector, array, and other basic words. And these options upon selection will give the user only words that fall within that category of words. So basically you're picking which genre you want to play from, and you'll only be given words from that specific genre. So when you choose the option in the menu and the game begins, a series of blank spaces, which will be the size of the word, so you'll have like an idea. Oh, okay, so it's eight letters, so it must be a word that's this long. So, and it will be generated on the screen, and the user will be asked to enter a letter, and you'll have 10 incorrect guesses. So if you exceed these guesses, you will be hanged, and the game will prompt the user telling them that they have been hanged. If all guesses are correct and the word is correct, the user will be told that it is the correct word. So it's pretty simple. So here are some screenshots. This is actually a screenshot of the menu and the menu animation, which you'll see in the demonstration. And that's the menu. 1 through 3, the options are given. And for any word that contains a space, please use the underscore character, because the program as of right now does not accept spaces for words like, for example, United States, where there are 2 different words, but the space in between has to be an underscore. And that's an in-game screenshot, which is, it shows that you have 10 incorrect guesses left, and the letter you guessed is in the word, and that's correct. And it shows like how far, what the word looks like so far, and it prompts you for another guess. So we'll switch over to the demonstration now. Okay, so here we are at the demonstration of the code and the program. So I'll begin by compiling it, and here you see the actual animation working. And now I'm greeted with the menu. So I'm gonna select, for example, superheroes. So I'll enter 1, press enter, and it'll prompt you and tell you that, hey, you're playing superheroes, so you know which genre you're playing. And I have 10 incorrect guesses left, and here's the blank spaces. So I'm just gonna guess a letter, A for example. So it doesn't have to, it can be either uppercase or lowercase. The program will change that to uppercase. So A is actually in the word, so I still have 10 incorrect guesses left, and that is correct. Enter another letter. This time it will be M. M is also in the word. I'll enter T. Okay, so sorry, T isn't in the word, so I am now left with 9 incorrect guesses. So I'll put in N, and N is also in the word. S is also in the word. U is also in the word. P is also in the word. E is also in the word, and R is also in the word, because I already know the word bank. So in the end, it tells you that's correct. Letter R is in the word. You guessed it. The word was Superman. And that's pretty much it for what do you call it? The superheroes segment of the game. I'll restart and go through the other segments and show like how to use the underscore for words with spaces in between. So here it is, generated again. I'll go for 2 geography. Okay, so I have 10 incorrect guesses. So it's the same process for all of them. So M is not in the word, so that was wrong. uh, C C is in the word. A okay, yeah. So if you have multiple iterations of A or any other letter, it will actually fill that in for you already. Like, so if you select A, you don't have to press A 3 times. So it's pretty easy that way. CAN. So that would be Canada, because I already know that. So, and then you guessed it. Here, let me just run it again and see if we can actually get it to show a word with a space in between. Nope, that's not it. Okay, so I have a feeling this word has a space in between. So U is not in the word. Okay, so what could this be? Let's put an S. Whoa, S isn't in the word either. A, okay, A. So guessing this is North America. Okay. And you can actually guess more than one letter at a time. So you can, for example, if you already know the word, you can just put RTH. Like, for example, that would make north, and it will fill in NORTH. So, and we have Okay, so we're left with that dash, that blank space in the middle, and we can't put a space in because that would count as an incorrect guess. So instead I put underscore, press enter, and it will say yes, that's correct. Letter underscore, which should be a space, is in the word, and the word was North America. So that's pretty much for the demonstration of the actual program. I'll go to the code now. Okay, so here we are at the code demonstration. So I'll be like going over the code. Let me figure out how to zoom in. You know what, never mind. Okay, so these are the preprocessor directives. So I have them in like a little box. So there's include IO stream, include string, which is clearly very important in this program, and vector. Vector is used for the word banks. Algorithm was actually part of the code that I got from the second party source, as well as seed time, which is used for the random seed function. So like every time you start the program, you have a random word. And CC type, I believe this is for the uppercase to lowercase conversion. And I added windows.h, which actually like reduces like the compatibility of the program with like other operating systems, but it can be removed. This is only for the purposes of the animation and coloring of the command line box. And using namespace std, pretty standard stuff. And I have my global variables, double user choice, which is it's the option that the user selects in the menu, like 1 through 3. Well, it's actually 1 through 4, because the fourth one is an Easter egg, which is not actually a very big part of the program. It's just an Easter egg. So 1 through 3, and string playing as, which tells you like in the demonstration we saw, it said you are playing as superheroes. So that's pretty much what it does. It figures out like which word bank you are using, and then that is put in the string. And we have the constant variables, max wrong, which is as the name suggests, is the number of wrong incorrect guesses you can get. So those are 10, and they're set by default 10. And this is my pointer. I used a pointer because well, to meet the requirements of the program as well as just make it simpler. And that basically every iteration of max underscore wrong, like used in loops and stuff, I believe it's used around 3 times so far, and that it just converts that to a pointer. So every time I use it in the future, it's just referring to the address of the variable. So it's not actually copying the variable over twice. And so we have global vectors. This is this only vector we have, and it's used for the word bank. It has like function called word bank, and those are all the vector. These like push. These are basically statements that push that word to the vector, and the vector then displays it as words. So that's a collection of possible words to guess. So, and these are function prototypes. So I have 1, 2, 3, 4, 5, 6 functions besides int main, and the char get guess function is used to actually receive the prompt and receive the guess from the user for the letters A, B, C, whichever one you want. And double word bank, this is actually a function that contains all the pushback statements for the vector, like I showed just a couple seconds ago. So that's all the word bank, what do you call it, words options. And we have double menu options, double menu op, and that's used for the menu options. That's not just the menu options, but it also displays what do you call it, like see out and everything. So and then we have bool clear screen, which is basically clears whatever was previously on the screen so it looks less cluttered, but it doesn't actually clear in the literal sense. It just adds like I believe 100 spaces between, so it clears the screen like as far as you can't see it, but if you scroll up you can in fact see the previous objects on the screen. And we have void and menu anim, which is menu animation, and that is the trivia hangman animation that appears on the menu, and that is just in a function just for the ease of future modification, just in general make it look cleaner and pretty much make it modular, so if anybody wants to use the code in the future they don't have any problems like having to figure out, oh, where's this, where's that. So that's what mainly the functions are used for in trivia hangman. So, and I also have a function called int addition game, and this is a function that's only used for the for the Easter egg. So it's only used for the Easter egg, and it has pretty much no relation to the rest of the program. So this is basically adds two variables using a and b, and b is also a default value. So here we are in int main, and we call 3 functions, which is the menu animation. The menu animation generates. Then we have the menu option. The menu option is the 1 through 3, 1 through 4 menu options that you are given, and then the word bank is called. So, and then in main consists of not too much, but this is all code that was second party. This is the heart of the program basically. So srand, this generates a random seed for giving you a random word every single time. And random shuffle, so it shuffles the word for a different word each time, so make sure that you get a different word each and every time. And we have the string word to guess, so this is a constant variable. And int wrong, which is the number of incorrect guesses that the user has made so far, and it compares that with the max wrong to see how many incorrect guesses you have left. And string so far, which is the word so far that is guessed. So when you see in the blank spaces that you have like 4 out of maybe 10 letters, and that's what uh, the so far is used for. And string used are the letters used. As you saw in the demonstration, it shows the letters you've already used, like A, M, B, C, whichever one you used, and that just every time you guess, it just adds to that this string. And system color 0A. This is actually used to generate the green and black background and font. So that's this doesn't work with every operating system. So if you want to like make this work with like Linux or Mac or whichever environment, whichever operating system that can support C++ and the compiler, it's just remove the system, the windows.h, and the sleep statements, which will have absolutely no effect on the functionality of the program. They're just there for like visual reasons and cosmetic, just make it look better. So, and we have cout you are playing as, which is as I showed before, the string playing as. So this tells you actually like which mode you're playing in. So for example, you are playing as superheroes, you are playing as geography, you are playing as cout for programming terms, or whichever option. And this is the main loop. So this one, okay, so wrong is less than int ptr. Int ptr is the variable, the pointer variable we use to what do you call it? Refer to max underscore wrong, which is 10, which is a constant variable as well. So it's like it checks to see the wrong words from the user and compares them with the max wrong. So like if it's less than that, and like the word so far is not equals to the word, and then it continues the loop. See how you have int ptr minus wrong, so that's the const 10 minus the letters you've got wrong so far, and correct guesses left. So this is basically just to show that, hey, you have 7 incorrect guesses left, and if you get past 7, the game will end and you will be hanged. And you've used the following letters, and it shows the used string, which adds up every time you guess a letter, and it shows the so far the word is, and it refers to the string so far. And here's character guess. Guess is equals to get guess used. Okay, so this actually get guess. Let us scroll down. Okay. So this basically checks to see if the guess that you've already made is not being guessed again. So here it begins the loop. Okay, so we left off at char get guess. So get guess, char guess equals get guess used. So this basically checks that the guess has not already been guessed before. So like if you're trying to guess M twice, it tries to it goes through the if loop and sees the word find guess is not equals to the string that's actually being entered right now. So like if I'm pressing N and the N has been guessed before, and at this point it clears the screen. Okay, this is just a clear screen function being called to clean up the screen at this point, and then it starts the what do you call it, the next prompt from the user. And you are displayed cout, that is correct if the guess is actually in the word. So and okay, so for unsigned int I equals 0, I is less than the word's length, and then I, what do you call it? Increments. Um, so basically, this checks so far. This is actually this is what tells you like how far the word is. Like so far, the word is, for example, the word was Superman, and you have only super done, so it'll show the so far. And that is end of if statement, end of for loop, end of if statement again. Else, okay, so if the guess isn't in the word, it basically tells you sorry, the guess isn't in the word, and it adds to the wrong. So that's the amount of wrong you got. So that what do you call it? So you have one less incorrect guess. So okay, so this is at the point where it shuts down the game. Like if you have been hanged. So if wrong equals in PTR, meaning 10, that is the maximum number of incorrect guesses you can get, then it displays tells the user that you've been hanged, and it tells you no, because being hanged is not a good thing. And then else, if you did not exceed the wrong incorrect guesses, then it tells you you guessed it, and the word was, it displays the word. And that is it for int main so far. We'll jump into get guess next. Okay, so here we are in the get guess function, and char guess is a variable that's used. And okay, so it prompts the user enter your guess, accepts the guess, and then it converts that guess to an uppercase right here. So it to upper, so it makes the guess the user entered, whether it was uppercase to begin with or lowercase. So it just makes sure everything is in uppercase. And then a while loop. So it's the guess is not equals to string n in the position, and it prompts that see out you've already guessed guess. So it checks to see like, hey, have you pressed M twice? Like, have you guessed the same letter twice? And then it prompts you again, enter your guess, and then it accepts the guess again, converts it to uppercase, and then it returns guess to, and then we call it in the int main and use it over there as we demonstrated. Okay, next is addition game. This is actually the Easter egg of the game, which has absolutely no relation to the game, besides to me actually the requirements for the program. So int r is a variable. R is equals to a plus b, so int a and int b. And in the function word bank, we actually have user choice if it's equals to 4. 4 is the option that is for use for the Easter egg. It basically uses it creates a variable called int z. Z equals addition game 5 and 3. Excuse me, 5 and 3. So it just adds 5 plus 3, and it basically just shows, hey, you found the random addition problem, the one and only Easter egg. It was 5 plus 3, it equals z meaning 8. And that's pretty much it for this function. It has absolutely no functional part in the program. If it's removed, it's removed. It doesn't really matter. The game will operate as it should. And now we are in the double word bank. Word bank is pretty much all the words in the game. So if you have like a switch made out of if statements, if and else if statements. So if the user choice is equals to 1, which is what they selected in the menu, so when they entered 1, it will open playing as superheroes. So you'll be given, there's 1, 2, 3, 4 words so far in the word bank, but there can be more in the future. So there's like, for example, Batman, Superman, Captain America, and Mr.Mayo, because he is a superhero. And so like these are like, you'll either receive one of the random 4 words that are in this part of the word bank if you do play as superheroes. And else if your choice is equals to 2 is geography. So you also have 4 words here. You have North America, Mexico, Canada, and Bolivia, and it will show that you are playing as geography. That's basically the ID of the word bank. And if you are playing as user choice number equals 3, that means if you selected 3, then you are playing as coding terms. So you have cout, integer, boolean, vector, and more can be added as you desire, I guess. And it's pretty simple to add. Just copy paste the statement and you just add the word. And it also tags, and it also tags as coding terms. And else if the user choice is equals to 4, we have the, what do you call it, the Easter egg. And the Easter egg is you just went over it, so skip that. And else if this is actually data validation, so if the user choice is greater than 4, so if it's like 5 or 6 or 7 or 8, whichever one of these options that don't really exist, it displays to the user that, hey, enter a valid option, and then it prompts user choice again, and then hopes for a correct valid option. And we have double menu op, which is menu options, and this is very simple. It's just, this is what prompts you to enter. So it just says choose the mode of Trivia Hangman that you want to play, and you're given options 1 through 3, superheroes, geography, coding terms, and option 4 is the Easter egg. So we don't actually tell that to the user just figures that out. And then we have the little prompt saying that for any word that may contain a space, please use underscore. So for any word that may contain a space, please use underscore. So, and then we have a bunch of endls, and we accept user choice, and that's pretty much it for menu options. And then we have the clear screen function. Has a integer called n, so that's just basically a counter. So you have a for loop, n equals to 0, n is equals to 0, n is less than 10, n plus plus. So basically it adds a bunch of new line spaces, and that's what creates that effect of clearing the screen. But it's actually just adding a bunch of spaces, like 100 or so, because it iterates this to 10 times. So that's how it clears the screen. Pretty simple. And then we have void menu animation, which is we have system color 0A, which is used again for the green and black look on the command line box. We see out each and every like line of characters used in a separate cout, so like retains the little formatting of it. And then I use a sleep command to make it give it the animation look, like how it was slowly falling into place. And so we use a sleep command. These are in milliseconds, so 600 milliseconds, 550 milliseconds, and it's just random. Try to make it look more realistic. And then we have a sleep statement at the end as well. For this program to be compatible, again, you have to remove the sleep statements if you want to use it on like a Linux or whichever other operating system besides Windows. That pretty much sums up. That's pretty much the entire program. Yes. It's approximately 270 lines of code. So before we end, I would like to go through the 15 items that our program was supposed to include. So number 1 was create and use at least the following primitive data types, which was int, double, bool, and char, which we use quite frequently. We have double, we have bool, we have int, and we have char right here. So, and those are used pretty frequently. And we have second one was relational operators, so it would be like equals equals, not equals, less than, greater than, and equals to, for example. And we were required to use 3, and I've used probably more than 3 so far. Here's one of the relational operators here, and another relational operator, so that's 2, and yet another relational operator here, and there's quite a bit more so far. Like, if I go through the code, like here's another relational operator. And so, and the third one was logical operators. We had to use 2, and I believe I used 2. Here's one. That's 1. What do you call it? There should be another one. Right here we have another relational operator, a logical operator, and yeah, that's it for pretty much the logical operators. And we needed unary operators, which would be something like plus, minus, plus, plus, minus, minus, and those were used quite frequently. And for example here, plus, plus. And we had to have for the fifth requirement, we had to have one or more if else or switch statements, and we have quite a bit of those. So we have if else right here, if else again, and we have if else if statements here. So we have quite a bit. And for the sixth requirement, we had to have one or more while or do while for loops. And yeah, that's pretty obvious. We use quite a bit of whiles, for loop, another while loop, so that was a requirement that was met more than just once. And for the seventh one, it was at least 5 functions. One must contain at least 2 parameters, and one must have a default value. And we have that right here. Okay, so 1, 2, 3, 4, 5, 6. We have 6 functions, and we have a variable with a default value and at least 2 parameters. So those would be the 2 parameters, and that was one requirement that was met. And the 8th one was include parameters at least 1 pass by value and at least 1 pass by reference. We use pass by reference right here for string add used, and we use pass by value here twice. Those are by val by default. And for the 9th requirement, we had to have declare, initialize, iterate, and modify an an array or vector, and we have one vector right here, and we modify it quite a bit. With the word bank, for example, these are all vector modifiers. And for number 11, we had to have comments explaining logic and operation of program at key points, and we have quite a bit of those, just little notes at the side of each major statement, and that shows, like, helps the person looking at the code understand it better. And 12, we were supposed to have animation or graphical interface, and that's where I had the trivia hangman display, the little animation, as you can see, this one right here, and that animation counts as what do you call it in animation. And meaningful variable names, so I tried my best to do the meaningful variable names because it helps me as well. So I use like menu anim, so that's pretty obvious. That would mean menu animation, clear screen, for example, and simple, easy to understand words like get, guess. So that basically means get the guess from the user. And word bank meaning It's a bank of words, max underscore wrong, meaning max amount of wrong you can get. And so that's something I think I met pretty well. 14 was documentation. And documentation, you can find it on pretty much every function here. Documentation. And 15th one was declare, initialize, and dereference at least one pointer. And we do that right here. We initialize a pointer right here. It's called int ptr, and we declare and initialize it. Sorry, and it's called int ptr, and it is max underscore wrong, so it refers to max underscore wrong, and we use it quite a bit. For example, for I believe we showed this. Show it again. So right here, you're using it wrong is less than 10, which is in PTR, so that's referring to 10. So that's used one place at least, and that's pretty much it for we had to have 15 requirements that had to be met, and I met all of them. And my voice is getting really dry because I've been talking for a really long time. And that is pretty much it, and we'll go back to the PowerPoint in just a couple minutes. Okay, so with the demonstration being over, we're back to the PowerPoint. So we talk about function usage. Functions are used intensively in Trivia Hangman, not simply for the sake of reusability, but for ease of modification and customization. Since the game is open sourced, functions are named appropriately, and the program is essentially divided into various functions, at least one function per major component. It was designed for future modification and expansion. Design of the program is modular. So it wasn't just for the sake of reusability, and in fact most functions aren't even reused more than once. So it was just for the sake of having neat and modular code. So like in the future, if somebody wants to add something to the word bank, they can just go straight to the word bank function and add there. They don't have to modify any other code. They don't have to look at any other code. They just go straight to the word bank and just change it. And parameters and functions. Parameters aren't used that much because the program doesn't have many calculations and other variables that would be found in most other programs. So it's basically almost entirely based off of characters, strings, and letters, and not having a lot of numbers. So that being said, there are two bival parameters which are used for the Easter egg, which would be to add the two numbers together, and one biref parameter called used, which is used to keep track of the letters that have already been used in the program, and we went over that in the demonstration. So special features and tricks. For the sake of simplicity, Trivia Hangman has only one Easter egg, and that is simply an addition problem which is solved by the program. Seriously, that's the only trick we could come up with, and it's not even a trick because it's just an addition problem. So how to get to the Easter egg: instead of selecting one of the three menu options, enter the number 4, press enter, and this will land you on the Easter egg page. We went over pretty much the entire PowerPoint in the demonstration, so that's why I'm going over this super quick. And known bugs. As far as the functionality of the program or the game is concerned, the game is fully functional and performs as intended. Sure, there are some issues like not being able to accept spaces like we demonstrated. We have to use an underscore, but that has been replaced with underscores. Maybe in the future we can let you replace it with a space, figure it out somehow, but at that point I could not. And citations. So the use of open source code was minimal. Approximately 57 out of the 270 lines were second party. The main algorithm of the program, like you saw in int main, that was the only major part that was from a second party, from like not coded by me or modified by me. However, everything else as far as the visual representation on the screen, the word banks, the menu, the animation, and nearly every part of the existing code was revamped. Even the code that I got, the 57 lines that were part of the Yeah, sorry about the last clip. My hard drive actually ran out of space, so it ended the video recording. And so I think I was talking about how every part of the existing code was revamped. So even as far as the incorrect number of guesses, initially when I got the code, it was the number of incorrect guesses you could have was 5. I just upped that to 10, and just like little things to modify the entire code. And so almost no part of the code is how it used to be before. So uh, that's pretty much it for the citations and the conclusion. Okay, so the difficulty level, it was pretty challenging for me, but nothing I hadn't already learned from the class. But it wasn't as easy to apply it in the real world as I had thought. Like we were doing programming challenges, but those didn't really uh exactly, like I was just doing that kind of subconsciously. I wasn't really thinking about it. I was just doing what it asked me to do. But when I tried to do it in my own program, it was kind of challenging, but I figured it out. Just a bit of googling and some common sense. And establishing and using a vector was probably one of the more challenging aspects because I really hadn't done that before. And when I did it, it wasn't that difficult. It was pretty much as easy as setting up an array. And the fun level, designing and programming Trivia Hangman was fun, but trying to meet all the requirements, even though I was done with pretty much the entire program, was not as fun. Like for example, I had to add an Easter egg to meet the requirement of 2 bivalve parameters. Uh, sorry, 2 parameters and one being default value in like the functions and stuff. But that was probably the biggest problem I had with like the entire project, was like having to uh, add more, even though it wasn't needed, like to the program, just to get it to meet the requirements. And besides that, it was a great project, and I really thank Mr. Mayo for like letting us have the what do you call it, the privilege to like spend an entire quarter just doing what we want to do, like programming what we want to program, and that was pretty awesome. And besides this half an hour podcast, which took a really long time, I think this was like an amazing project. Evaluation. My evaluation on my own program was pretty good, since everything I coded worked pretty much seamlessly with pretty much no unexpected issues. Besides, while compiling, we had like improper syntax, but that wasn't really a big deal. So there wasn't really anything that went wrong or didn't work. So, what I learned from this project was pretty much a recap of the entire school year, and it really helped me understand C++ better because it helped me apply it by myself in a real world environment, like in an actual program instead of a programming challenge. Uh, so it was pretty awesome. I mean, like I feel like I got a good understanding of the basics of C++, and I can use it to create like small programs pretty easily now. And any questions can be asked on the Edmodo post for this presentation, which will be on Edmodo shortly. But I think I've exceeded the time limit like quite a bit. I actually thought 30 minutes would be a really, really, really long time, and it would be really hard for me to talk that long, but apparently it went pretty far. So I think I'm close to 35 minutes or maybe even more. But yeah, it was pretty awesome having Mr. Mayo this year, and everybody in the class was pretty awesome, and this project was pretty awesome too. So, yep, bye.